welcome back. Let's do question 415. Sketched below is a graph of h of x is equal to 1 over x plus p plus q. The asymptotes of h intersect at this point. Right, from the previous questions, we managed to find the value of p and the value of q. So meaning that h of x is 1 over x minus 1 plus 2. So the question says, determine the values of x for which negative 2 is less than or equal to 1 over x minus 1. Determine the values of x for which negative 2 is less than or equal to 1 over x minus 1. If you check, we can actually write this inequality in this form. If we bring negative 2 to the right hand side, it becomes what? 0 is less than or equal to 1 over x minus 1, then plus 2, meaning that this is our h of x. Then we can rewrite this inequality in this form. Let me just show you something. If I say 2 is less than 3, if I say 2 is less than 3, I can write this inequality as 3 greater than 2. 0 is less than or equal to 1 over x minus 1 plus 2. We can write this as 1 over x minus 1 plus 2 is greater than or equal to 0, like what I've done here. This is our h of x, like I said. This is our h of x. So where h of x is greater than or equal to 0. What is the meaning of that? So greater than 0 means above the x-axis. For which x values is this graph, h of x, above the x-axis? This is our x-axis. We found the x-intercept of our function. It was 1 over 2 in the previous question. We got it here. It was 1 over 2. Right. Where is the graph above the x-axis? So this part, let me highlight the part. This is the part which is above the x-axis. This is the part, let's not forget this part also, which is above the x-axis. You see that? So that's where the graph is above the x-axis. For which x values? That's the question. So want where h of x is greater than or equal to 0. It is equal to 0 at half, at 1 over 2. So it means 1 over 2 is included. And then when x is less than 1 over 2, going to the left, remember the number line. The number line decreases as you go to the left, increases as you go to the right. So when you're going to the left this side, these values are what? Less than 1 over 2. Okay? But now they say less than or equal to 0, so we have to include the 1 over 2. So when x is less than or equal to 1 over 2, h of x is greater than or equal to 0. H of x is at 0 or above the x-axis. That's what it means. And then let's not forget this side, this arm. Let's not forget this arm. We're moving from 1. This is 1. X is equal to 1 here. Then we're going to the right. So it means when x is greater than 1, we cannot include 1 because x is equal to 1 is the asymptote. The graph will never touch the asymptote. This is our solution. H of x is greater than or equal to 0 when x is less than or equal to 1 over 2, or when x is greater than 1. Which is the solution for this? Negative 2 is less than or equal to 1 over x minus 1 when x is less than or equal to 1 over 2, or when x is greater than 1. Now, we can do this algebraically, but we don't usually use it. Okay, we just interpret the graphs. But if you want, you can continue and watch how it is done algebraically. Determine the values of x for which negative 2 is less than or equal to 1 over x minus 1. Right, when you're dealing with inequalities where the variable is in the denominator, it is better to use the number line. Okay, so we must have the number line. right? The number line is actually the x-axis. You know that when you're saying a function is greater than 0, it means above the x-axis. When you're saying less than 0, it means below the x-axis. We have to be careful here. Let me give you an example. If I say 2 is less than 3, do you see that I can write this thing as 3 is greater than 2? Do you see that this and this is just the same thing? Okay, so that's what we're going to do here. So this is just the same as 1 over x minus 1 is greater than or equal to negative 2. Then we can bring the negative 2 this side. So it becomes 1 over x minus 1 plus 2 is greater than or equal to 0. So we want where the function, where this function is greater than or equal to 0. So what do? We have to get the critical values. One, we get the critical values. We're going to get the critical value from the denominator. So x minus 1. Is it possible for x to be 1? No, it cannot be 1. X cannot be equal to 1 because if x is 1, then it becomes undefined. So x cannot be equal to 1. So that's a critical value. Let's put 1 here. And then we put an open dot because 1 cannot be part of the solution. Right, the other critical value, we replace this one with an equal sign. Then we solve for what? We solve for x. Right, so it's 1 over x minus 1 plus 2 is equal to 0. We're finding the critical value here. Multiply everything by x minus 1 times x minus 1 times x minus 1 times x minus 1. Okay, then what do you get? Right, this x minus 1 divided by x minus 1 is 1 plus 2 times x minus 1. 0 times x minus 1 is equal to 0. Then this is 1 plus 2x minus 2 is equal to 0. Then 2x minus 1 is equal to 0. Then bring 1 to the other side. 2x is equal to 1. So x is equal to 1 over 2. That's another critical value. And then where is half? Half is here. 1 over 2. Right, 1 over 2 should be included because it's greater than or equal to there. So this should be included. It's a closed dot. We can substitute into our function and see what we get. Are we going to get a positive value or a negative value? So you can substitute any value which is less than what? Less than half. Let's pick a nice value, an integer most of the time. Let's pick 0. 0 is below half. Let's put 0. So it's going to be 1 over 0 minus 1 plus 2. 1 divided by negative 1 is negative 1 plus 2, which is positive. The answer is positive there because positive 1. So this one is positive. Okay. Greater than or equal to. So we want that part. It's fine. Let's come to this side. I think it will be easier to get an integer this side. Any value greater than 1. Let's pick 2. We're going to put 2 here where there's x. So it becomes 1 over 2 minus 1 plus 2. Right, this is like 1 over 1. 2 minus 1 is 1. 1 over 1, which is 1 plus 2, which is 3. So it's positive again. So it's positive this side. So we want greater than or equal to 0. So this is what we want also. But 1 cannot be included. Let's pick now anything between 1 over 2 and 1. Can be a fraction. 1 over 2 is 0, 0.5. 0.75 is 3 over 4. Let's pick 3 over 4. So I'll say 1 over 3 over 4 minus 1 plus 2. 3 over 4 minus 1. 1 is like 4 over 4. 3 over 4 minus 4 over 4, that would be what? It would be negative 1 over 4. So it's 1 over negative 1 over 4 plus 2. Right. 1 divided by 1 over negative 4 is just the same. You tip n times. Dividing by a fraction, you tip n times. So this becomes negative 4 plus 2, which is negative. Right. This part here will give us negative. Then we don't want this because we want greater than or equal to 0. So our solution is here and there. So it means our solution is what? Solution will be x less than or equal to 1 over 2, because 1 over 2 is included. See, close dot. So x less than or equal to 1 over 2, or x greater than 1. 1 is not included, so x greater than 1. This is our solution.